Hi, everyone. Let's go over another FRQ from the 2019 exam. This time we're going to look at FRQ number 7. Again, this is one of the shorter FRQs. Let me pull that up here. Okay, so this is also a gene expression question. So if you take a look at this question, it says a researcher is studying patterns of gene expression in mice. The researcher collected samples from 6 different tissues in a healthy mouse and measured the amount of mRNA from 6 genes. The data are shown in figure 1. And you've got a legend saying if it's a white square, no mRNA was present. If it's gray, a moderate amount of mRNA. And if it's black, a high amount of mRNA. And you've got, it looks like 6 different genes they looked at, E, F, G, H, I, J. And here are the tissues they looked at: liver, heart, brain, kidney, pancreas, and skeletal muscle. And now, first thing you should ask yourself, do I see any pattern? Is there any gene that's not expressed at all? And if you look at it, you see it looks like gene J, there is no mRNA present for that in any of those tissues. Now, is there any gene that's expressed in all the tissues? Yes, there is. Which one is that? And even though it's not expressed at the same level in every tissue, gene G is expressed in all 6 tissues they looked at. So let's take a look at the question. A, based on the data provided, identify the gene that is most likely to encode a protein that is an essential component of glycolysis. Provide reasoning to support your identification. So let's think about glycolysis. Now, glycolysis occurs in which part of the cell? That's right, glycolysis occurs in the cytoplasm. So what cells do glycolysis? And if you said all cells do glycolysis, you're also correct. Even prokaryotic cells do glycolysis, okay? So we're looking for a gene that is expressed then in all cells, if it's a gene for glycolysis. So, and that would be gene G, because it's the only one that's expressed in all cells. And your reasoning is that glycolysis is a necessary process for life. It's found in all living cells, so it has to be gene G. Now, part B said the researcher observed that tissues with the the researcher observed that tissues with a high level of gene H mRNA did not always have gene H protein. So the gene H mRNA was present, but the gene H protein wasn't. Provide reasoning to explain how tissues with high gene H mRNA levels can have no gene H protein. So if you have the mRNA, but you don't have the protein, what process did occur to produce the mRNA? What process produces the mRNA? And that's right, it's transcription. Now, if you have the mRNA, but you didn't get to the protein, what process did not happen? So what process takes the information in the mRNA and uses it to make a protein? That's right, that process is translation. So the reasoning would be that for some reason transcription occurred of that gene, but translation did not. So this was a 3-point question. All you had to do to get all 3 points was say that gene G was the gene that was most likely to be involved in glycolysis and provide the reasoning. And the reasoning is because glycolysis occurs in all cells, and gene G was the only gene that was expressed in all cells. That's your 2nd point. And then your 3rd point was to say that since gene H mRNA was present in some cells, but gene H protein was not, that transcription must have happened in those cells, but for some reason translation did not. And those were your 3 points for this question. And if you look at this question, you'll also notice there's 3 words that are bolded. This is not always true, but it's often true that each of the bolded terms is going to be worth at least a point. Anyway, I hope that was helpful, and you guys have a great day. Bye.